Oh, maybe we want to go back. We want to ask you guys
yes,
what
we
you
have a
know
question.
about 3D printing. Does anyone have anything? Anything at all? You came here for a reason.
How many of you know how 3D printing works as like a rough idea? You guys have like a rough sense of how it works? Okay. Have any of you seen one working before? Okay, so you guys have been in the presence of one. That's good. That sounded a little weird, but yes, you've been around them. That's good. Okay. Cool.
Okay. So essentially what 3D printing is it's a new way of making things. So instead of typical manufacturing where you have molds and you are pouring things into other things, this is a layering system. So there's tons of different types of machines and there's tons of different materials, but the exciting thing about overarching 3D printing is that it is a way to layer materials on top of other materials, and then you have an object. So an exciting thing about that is you can print something in this orientation and you do not have to assemble it after the fact. So like a typical chain or mechanical part, you would have to make all these parts individually and then assemble them later. This was printed with support material that then was chipped away, and then you have this mechanical part. That's very exciting for entrepreneurs who are making sort of mechanical-like parts. So that is one of the cool innovative things. And then you want to go over our misconceptions?
Yeah, so there are a lot of misconceptions when it comes to 3D printing, especially for people who may not have had direct contact with the technology before. And we always like to kind of dispel these quickly before we get into how things work so that we can start building a sense of what is possible right now with the technology, and then we can actually help you push the boundaries a little bit. So it's not a magic box. I know that's like one of the first things we like to tell people. It's not really a thing where you can press a button. I mean, a lot of like news outlets and people, when 3D printing became a really popular industry, that was sort of what was on a lot of people's minds, is that you could press a button and then you get something out of like an oven, like the Jetsons kind of thing. It's close to that, but we're not quite there yet.
Can you save a 3D file onto say, could you have a library of objects on a 3D printer?
Yeah, so some printers can store data, can store your files, and then you can reprint them. That's totally possible. But there is a whole process when it comes to 3D printing that we can kind of talk about. Not only is there the printing part of it, but there's also the post-processing, and I think that's a large part that people don't actually know about. We can talk a little bit about that. Not all 3D files can be printed, so just because you have a 3D file doesn't necessarily mean that it will come out well of a 3D printer. And we can also kind of go into that a little bit, but like some objects are really delicate, or some objects will have features that just physically can't print.
Right, and then you also have files that are generated in softwares like SketchUp or other softwares that are more for rendering and are more for VR 3D spaces, and those files can be converted to printable files, but they do not necessarily automatically have printable geometry.
Yeah, exactly. Let's see, not always food or skin safe. So this is something that I'm hoping that everyone should know about, but a lot of common materials you're going to come across are not food safe. So I know there's a lot of talk about people printing things from FDM machines, and we'll talk a little bit about that technology in a minute, but out of ABS plastic, and that plastic's not FDA approved. It hasn't been approved for coming in contact with food. And basically due to the 3D printing process itself, it actually makes it pretty easy for bacteria to get stuck inside the material. So yes. Be aware of what materials you're printing with before you start developing a product. Yes. If the end goal of the product will use 3D printing in the production process. So.
Yeah, because I know that when I was introduced, I was like, I am going to print a mug, and then I will drink my coffee out of it.
And then we said, don't do that.
And Demery goes, no.
Now, with that said, though, there are manufacturing processes that utilize 3D printing that do make food safe end products.
Right.
So we actually have a food safe product at the studio that you can use, and also Shapeways, which we can talk about too, is an online resource. They print porcelain and then they glaze it with a food safe material. So
Right, so you just have to be careful about what printer you're using.
Yes.
And whether or not that is something that you can put something in and then put that in your body. So
Exactly.
we just have to be careful about that. Yeah,
Exactly.
go ahead.
When you talk about it's not skin safe, it cannot come in contact with it. I cannot touch it.
It's, well, when we say not skin safe, it's a reactive, most of our plastics that you'd come in contact with are non-reactive, but if you end up like making a ring out of a certain material, it may leave a rash. You may get mild skin irritation. It's not gonna hurt you, but some people may be more sensitive to the material.
Right.
I know there's one material that we have at the studio that I'm extremely sensitive to, that I need to be careful when I'm handling. But it's really more about exposure. Like, you're not instantly going to react to it, but sometimes over time your exposure will cause problems.
Right, so we do like to treat these materials as prototyping, as essentially like a means to an end. So this beautiful donut that I made is not necessarily can go in a museum, because it will get sunburned and it will change colors. It is not archival.
Yes.
So this is a means to an end. There are ways to treat materials to make them food safe and to you can use a UV spray to avoid discoloration, but typically we like to treat them as prototyping materials.
Yeah. The end kind of goal is just to keep in mind that you're very aware of materials that you're using and what the material properties are. And that's a question you should always ask yourselves when you're prototyping, especially, and we're kind of talking about prototypes that will become products using 3D printing. So even like the prototyping stage, it may not matter what materials you use, but if you're planning on doing like use cases, or you're planning on actually really testing what you're making, you should, through 3D printing, you should know what your materials are and how they work. 3D printing is not always the cheapest, fastest method of prototyping. And this is really important. As much as we use 3D printing all the time in our work, there may come a time where we can recommend better prototyping solutions that are not 3D printing. So it's good to know when it's appropriate to print. And you may not know that. You'll get the idea when you're trying to do things. And that's, there's really no way to know exactly which direction you should go. You should definitely view multiple options before you dive right into printing.
Yeah, like I had a friend who was like, oh, well, why wouldn't you just 3D print me an Excel sheet? And I was like, well, there's paper. Like it's kind of those types of things.
Yeah, exactly.
That Excel sheet will cost you like, $30 when you could just print it on paper. So
Exactly.
these are the kind of things we're talking about.
Yeah.
Because it is exciting and it is sensationalized, and we do want to advocate for it, but then
absolutely.
just be cognizant of the times when it's smarter to do more conventional ways of making.
Exactly. Like we had an artist that came in that wanted to 3D print a massive sculpture for a public art display. And we sort of told him, what you're going for could be done faster and easier with a CNC mill and foam. And then you can coat it in fiberglass. And then you're going to get exactly what you want, which is what people like Jeff Koons do when he wanted to 3D print it and then electroplate it, and it was just this big process that would have cost him a lot more money to do the 3D printing route. So it's just good to be aware of what your options are before you jump right into 3D printing. You can't combine different materials in the same printer, and we'll talk about this too. Sometimes we get requests for people who want to print metal and rubber at the same time in the same print, or like metals and plastics, or porcelain and plastic. It's not something we can do yet. People are working on it, a multi-material printer. Now there are printers that can print in like rubber plastics and rigid plastics, but it's still inherently the same material. It's just different polymers of the same plastic. So
Right, yeah, so those are two different machines. Try to think about what you're making, especially when you're starting off, as just one material.
Yeah.
But you can think about color. So this is one material, different colors.
yeah, exactly.
Not to quell anyone's excitement.
And then you want to talk about this one? Embedding?
Yes, embedding. So a lot of people get really excited about microchips, for example, and like, can I 3D print something, put a microchip in it, and then continue 3D printing over it so that it is embedded in the object? Or like, can I 3D print something, put water in it, and then continue 3D printing, and then you have water inside of like a globe or something? No, just like you can't.
Yeah.
Some people and some machines you can stop and then start again, but you typically end up with printer flaws, and most shops will not do that. So
just keep that in mind.
Keep that in mind.
Now the studio did recently get a machine that will allow you to embed things into plastic parts. If that is something that will really be helpful to you. However, because the build chamber is heated to a certain temperature, you need to make sure
What's
the
the
parts
temperature?
you're embedding, I think it's, I want to say it's 200 degrees Celsius.
Uh-huh.
So you want to make sure the components you're putting in there are not going to get ruined at that temperature. Most things probably can't survive that temperature.
Anyways, well, the most exciting thing about these misconceptions is that while maybe dampening your excitement, we are also willing to experiment. If you come to either of our facilities and you have an idea,
Yes.
come at it with all your ideas. Let's talk about it. We'll figure it out.
Yeah.
At the studio, there are consultations, and you can talk about everything you could possibly want to do, and they will help you narrow it down into things that are possible at NYU with our services.
Okay, so let's talk about what 3D printing is. And Blair pretty much already summed it up. It's essentially just a process of laying down materials and just basically what we can call them like different layers and then stepping them up so that you get a 3D object. And you actually see this owl is being printed with an FDM printer, an Ultimaker actually. You can see the logo in the background. And this is an example of FDM printing, which is something I brought up earlier. This is the most common 3D printing process. It's the cheapest and the easiest to make. It's just two motors essentially, and then something that can melt plastic and then squeeze it out of a nozzle like a glue gun. That's essentially the process. And then you need a software that can slice a model and then build it up in layers. That's really all it is.
Have you guys heard of a MakerBot?
MakerBot.
Some of you.
Some of you maybe MakerBot. It's probably the most common company. They were recently acquired by Stratasys. Maybe not recently, but.
Yep.
So yeah, most of the facilities, like the co-op has FDM printers, we have FDM printers, and
the eLab has
eLab has
FDM printers.
FDM printers. So it's the most common technology you're going to run into, and it should be the one that you approach first, unless you know what your needs are specifically, because it's usually the easiest one to use, and it gives you pretty quick results.
Yep.
So yeah, that's pretty much it. There's different types of materials you can print in. This isn't the only technology, and we'll talk about other types of printing technologies, but this is the most common.
Yes, so this would be FDM, and if you guys might not be able to tell from where you are, but you also might, is that there are like very clear layers, very clear striations where it is being laid down. So this is like a lower resolution print with high definition. So I'll actually pass around some FDM prints so that you guys can get a good idea of what that looks like.
For something like that to be made?
So something like that, now this is obviously a sped up video, this isn't real time. Something like that could take anywhere from, I want to say like 6 to 12 hours depending on the printer. Different printers will print at different speeds. I know the Mojos are notoriously slow, but you're going to tend to get a better resolution than most of these types of desktop printers. So these are the lower end ones. The lower end desktop printers tend to print a bit faster than the higher end ones.
Right.
But you're also getting you'll get a lower resolution print out of it. The lower the resolution, the faster it can print. You can kind of think about it that way. The higher resolution, the more layers, which means more print time.
Yeah. Yeah. So one of our, do we want to go into the different?
Yeah, let's talk about different technologies.
Okay, great.
So I'll go ahead and talk about this one just because I know what these are. So the top left, you can see what that is cement, and that's actually a cement printer in China that's printing a house. So this is an example of what people are doing with printing right now. They're printing houses in China, which is great. It's really cool. The printer is a warehouse, is the entire 3D printer. And all it does is move around the warehouse and print this out. So they're printing houses now, which is excellent. And this is actually the same process as what we were talking about. It's liquefying a material that's normally solid, and then it's just using the air to dry it and harden it. Some processes use lasers to harden the material. Some of them use light, and some of them use chemicals to harden the plastics or whatever you're working with. So the upper right is actually what's called SLS. Actually, is that SLS? Is it using the laser? It's not even telling me if it's using the laser. I'm going to assume,
This guy up here?
yeah, that's SLS technology. Or is it binder
powder.
jet? Okay, might be. Well, anyway, so what this is, it's using powder and probably what is these inkjet print heads that are literally jetting out like Elmer's glue with ink. And what it's doing is it's literally, think about how a 2D printer works. It lays the ink down where it needs to. Same process, but it's doing it on a bed of powder. And everything that doesn't have the ink on it is not going to be hardened or dry. So you're going to be left with, like Blair's donut, for example. So it's literally kind of like a 2D printer that's just printing it in layers on powder. And then what you can see is happening is that the printer is spreading another thin layer of powder over the surface of what's already been printed. And then it just builds it up that way, which is really cool. It's probably one of the oldest technologies, one of the older different technologies of 3D printing. Companies like Boeing have been using 3D printing for much longer than most of us have heard of it. So they've been using 3D printing for maybe 30 years now. So it's actually been around for quite a long time. It's just been pretty prohibitively expensive to get a printer, and most companies didn't need it. Companies like Boeing that need to iterate parts for planes really quickly would use this type of technology to do so. And now they're actually using 3D printers to build the parts that are going in the planes directly nowadays. The lower left, this is a liquid resin printer. This is a little different. This, I believe, is a DLP projector that is curing the resin for each layer. So basically there's a DLP projector at the bottom of the vat. And as this platform sits at the bottom of the vat, and then as the DLP projector is just literally projecting light in a shape. And that's how it's building up the geometry. And then basically this pulls up and you're left with a solid object. Resin printers are great for high resolution. Prototypes, probably not great if you need specific material qualities because it's quite brittle plastic, but it is a really high resolution plastic print. So it's good for printing very small things like that Eiffel Tower.
Yeah. Do you guys have any questions about what we've seen so far? Okay.
And then I'll just bring up this one. This is actually at the Shapeways factory, which is in Long Island City. This is an SLS printer. This is if you're familiar with Shapeways, which many of you may not be, they actually offer a nylon material that you can 3D print in, which has a great amount of flexibility to it. And it's a really versatile plastic. It's also very easy to dye. So if you're looking to get really beautiful colors with your prints, nylon might be a good way to go if you want to experiment with your own dyeing. This is an example of a dress that was 3D printed. I believe was Nervous Systems is the company, and they specialize in 3D printed outfits as well as jewelry. So you should check them out. They're a really cool company. But yeah, that's an example of a Nervous Systems dress. They're pulling out of the powder after it's been printed. And then after that, it needs to be, all the excess powder needs to be blown away. And then the part either gets polished in a polisher or it gets dyed and then polished. The SLS is actually, this powder is skin safe. It's because it's nylon. It's a nylon material. It is non-reactive. So that's actually a skin safe plastic. Okay.
Okay.
Blair.
So for you guys, entrepreneurs, if you're here, we assume that you are entrepreneurs. Do you guys have any 3D printing related entrepreneurial ideas that you guys want to discuss that we can talk you through? Does anyone have anything at all? Yes.
I'm thinking of producing a prototype that is like a dispenser for medicine.
Mm-hmm.
And then I'm imagining it to be a shape of kind of skitter, but I don't have like a specific ideas on what it will look inside of it.
That's totally doable. We
Yeah,
can
that's
totally
something-
do that.
Absolutely.
Especially if you wanted to print something for people who want to potentially buy into your idea. You could create something in 3D modeling software, and we could, point you in the right modeling direction, and you could create that, print one, And that would be lower cost for you than going to anyone else, because most manufacturers are going to want to print more than one of something, and that ends up being quite expensive. And what's really great about 3D printing is you only have to do one. So it's gonna be faster. For example, there's a lot of architects out there who make models for their houses or buildings, etc. And what's great about 3D printing is that those models are made out of styrofoam and like wood usually, and they're very tiny and they're very hard to edit. But if you're doing it in 3D printing, if you're doing it in the virtual world, if you need to make any edits, you can do like a quick little edit and then print it again. And so that is a really huge benefit of prototyping. You can make minor changes quickly. And that's not necessarily true for other manufacturing methods, which then saves money. And we did say that there are a lot of materials that aren't, skin and food safe. There are some. And so for those materials, you can use them. There's this material called Ultem that is going into the Boeing flights. And it's getting printed and it's getting, built right in, ready to go. So you can go ahead and you can test these materials, and you can do multiple iterations. And when you present an idea to someone with a 3D print, it's going to be a lot more impressive than drawings or even a digital file that you rotate for anyone.
Like a render,
having a physical object that people can touch and play with. For example, this mechanical turtle here is a little bit more impressive than me showing you a digital file. So that's always like a good sell. And because 3D printing is still pretty sensationalized, you have that on your side as for now.
Yes.
Yeah, I think that's.
Yeah, and then there's also, I know this bottom one might be confusing, but tooling is like the process of traditional manufacturing where you build, giant aluminum blocks that then you're molding your plastic, right? What this means is there are some 3D printed materials where you can actually create the mold yourself. You don't need to get them milled out of giant blocks of metal. Some plastics can actually resist the traditional manufacturing process, so you can go straight to manufacturing from your prototype, which is actually pretty cool. And it will save you a lot of money. I don't know exactly how expensive that whole process is, but I hear it's pretty prohibitively expensive for a lot of small companies. It depends on the material, but there is one that's good for up to, I want to say 1,300 degrees Celsius, something like that. And it's also about pressure as well, like how much pressure can the materials withstand. And that's the Ultem material, which is the Ultem 1010, which is a high impact, high heat resistant material. And it's great for like vacuum forming as well, which is a really common method of manufacturing.
I think this is Ultem.
That's the Ultem.
This is Ultem.
Yeah,
it's FDM. That's the way we made it. But
I don't know if that's 1010, but that's one of the Ultem materials.
Yeah.
One of them's the aerospace one, which means it's ultralight. It's good for airplanes. The other one is the high impact, high resistant material. So, cool.
Okay.
Tips and tricks.
Tips and tricks. First and foremost, do you guys have any questions? No.
Anything at all?
Anything at all?
We'll entertain anything. Okay.
Can you talk about
yeah.
Ultimaker 3 when we're doing this?
We can talk about Ultimaker a little bit. Yeah, I haven't experienced the Ultimaker 3 directly. I've heard great things about it though.
I mean, it's the same sort of FDM, technology fused deposition modeling, and it will take PLA plastic or ABS. Which one do you guys use, Carol?
I think both.
Are you guys getting the new Ultimakers?
We have it.
You have the 3, right? There
Yeah,
you
they
go.
have it.
So it's here. You guys should try it out. Good.
Yeah.
What we had previously, so.
Good.
Yeah.
That's great.
What?
Is that at LaGuardia?
No,
It's
here,
here.
downstairs. Yeah.
Oh,
There are a few, there's a few different reasons why you would pick one or the other. ABS plastic is the plastic you will find in your commonplace Lego bricks. We like that one. Why would you use PLA? I think it's a little bit lighter.
It's a little bit lighter. It's technically like more organic material, so it's cheaper. It's easier to print with. That's kind of the big reason people use PLA plastic. It's ABS, because it needs a heated platform usually, PLA doesn't. So
Right.
it's actually a little easier to print. The prints tend to come out a little bit, not better, but they won't fail as much generally. ABS plastic, because it requires a certain temperature. If it cools too quickly, they can delaminate. But you will generally get a better surface quality with ABS plastic. That's kind of the thing.
What do you mean by delamination?
That's basically when your layers will split and that's usually a result of rapid cooling of your materials while it's printing. Like, these are a lot of things you have to think about. Like, you guys don't have to think about it, but we do when we're printing for you.
Yeah.
We have to think about a lot of these things, but
It essentially just, I mean,
it just
the
means your
layers
print
that
will
you guys were
split
looking at
at the
would like
layers.
start peeling up. We would call that a failed print.
yeah, exactly. And that's not pretty. Like, you don't want that for your prototype. So.
Yeah, and so that's actually the thing about the Ultimaker and the MakerBot versus a lot of other high-end printers out there. So those printers are cheaper, and you can probably have them in your home. But the downside with how cheap they are is you do have to kind of like level the bed tray, which is what you're printing on, to make sure that it is you're printing on a flat surface. There's a lot more user error with Ultimaker and MakerBot.
Well, it's because you're doing more of the calibrations, and
Right.
it's less automated,
Yes.
which could be kind of fun though. Like,
Well, you built your own 3D printer.
Yeah, like if you like to tinker and you like to you want to be in full control of your printing process, it's great to get one of those smaller machines, because you can literally control every single aspect of that printer. The larger printers are more automated. You have less control,
Right.
and you don't want to have control of the big ones, because it's not generally a good idea. But the smaller machines, the FDM printers, the common, desktop 3D printers, those are great if you're really into.
Yeah, and you get to be the
DIY,
mechanic,
tinkering.
and you get to understand all the specs. You can control the layer thickness of how
Yeah,
thick.
you can control how fine it is, how fast it prints.
Mm-hmm.
Yep.
Yep, the temperature, all that is yours to control.
Yes.
So, and yours to ruin your print or to make an amazing print.
Exactly.
But yeah, the less automated,
Yeah.
the cheaper and the more sort of consumer aspect of those printers. Okay, so what are we looking at here?
So these are just general tips and tricks. And I'll talk about these kind of animations in a minute. But the first one, understand your materials. We talked about that. Like, know what you're printing in. Even if it's not necessarily relevant to your final output, it's still important to know maybe there are materials that will give you a better prototype. And those are questions you should ask yourself while you're working. Maybe you don't like the look of what you're getting. There are other processes out there that you can use. There are other ways to 3D print. So.
And you can ask us. People come to us all the time with projects. They ask us questions.
Yeah.
And we know all the answers.
Yeah, we both offer free consultations. So if you're starting to think about 3D printing of something, ask us what your project is, and we can probably direct you to a technology, if not, help you get started.
Exactly.
So.
We are first and foremost tied to an educational institution. So we do teach just as much as we run 3D printers.
Yeah. Prioritize function over flourish at first. That's usually, a lot of these are from people who have come to us, and these are our experiences with helping people get their prints made. A lot of people kind of micromanage when they're first starting to rapid prototype, but we like to tell people it's actually going to be better for you if you make things really simple and then get complex as you're prototyping. And that kind of goes into the iterate one. Don't be afraid to make as many iterations of your project as possible. Usually it's pretty rare that you're gonna get something and it's gonna be perfect the first time. And that shouldn't be a thing you're afraid of. That should be something that excites you. Like you should get happy and excited about the fact that you're getting so much closer to exactly what you want. So
yeah, it's not, it's not a traditional way of making things. It's not like you're making something out of clay or you're painting something. You can make giant edits without destroying your original.
Yeah, and it's so easy to do, which is what's so great about 3D printing. You're not like re-sculpting something by hand, or you're not retooling your entire manufacturing process. You're literally just, making a couple edits in the machine and then getting another sample out. So it makes it faster and better and easier on the designer, especially. Set a timeline. And so we'll do choose your challenge. So choose your challenge is basically just like make sure, like pick, again, with the prioritize function over flourish, like pick what you want to focus on and then go for that. Try
Yeah.
not to get too preoccupied with, at least in the 3D printing world, with dealing with extra things you don't need to worry about.
Yeah,
Try
what
and
is the problem
simplify.
you're trying to solve?
Yeah, what is the problem you're trying to solve, and then simplify that so that you're getting the direct results you need. Set a timeline. Before you start thinking about prototyping, you need to sort of figure out what your timeline is for your project, where you're at in the design process and the production process. And you need to start contacting whoever's going to do your prototyping for you, or if you're going to do it yourself, you need to make sure you have enough time to factor in how long it may take for a vendor to print the thing out for you and get it to you.
Yes.
And you also need to talk to them and figure out what your time, like what production on average takes for 3D printing. Because some printers are really fast, but then some printers take days or weeks to get your parts out. So you need to make sure that you're factoring that time into your whole project timeline.
Because, for example, you could print something like this in 6 hours, 5 hours?
Less, 4 hours.
4 hours. But then this, which is like a super high
that
dense-
took us weeks to get that printout because the first couple files were unprintable.
Because it is
it's
a
very
bone marrow scan.
Exactly.
So it's super, this is a really large file, so it took forever.
It took forever.
And then I'm printing, oh yeah, feel free.
Yeah.
I'm printing something right now that is, what did we decide, 19 inches, and this is gonna take 61 hours. It's like this
And that's
big.
just printing. There's also a large part of the time is for post-processing, which is removing support material, cleaning. You saw them take that dress out. That's gonna take a couple days to clean. So even though the print is technically finished, there's a lot of work that you may not see that the vendors are gonna go through to help make sure it looks as pretty as it should.
Yeah, so think about print
think about
time.
that. Think about print time especially when you're working on your timeline for your entire project. Post-production, again, be aware that there will be post-production necessary for your projects. Even if you're printing it at home, you're gonna get support material you're gonna have to remove. Like if you're printing it here, you're gonna have to get support material removed. You may need to do a little bit of sanding to get really smooth edges. If you're experimenting with post-production on FDM prints that will give you a smoother surface, that's gonna take time and research. So just kind of factor all that stuff in. But post-production, most 3D prints are made to be post-processed. Most 3D prints are not, consumer ready or production ready right out of the gate. So there may be some work that will need to go in to get them to that point once you get the print in your hands. Scan your body is, that's actually more relevant for the cosplay one, but it's okay. So yeah, scan your body. If you're looking to do projects that are like to fit people's bodies, so if you're working on certain fashion applications for 3D printing, definitely getting a body scan and modeling those parts off of an actual human body might yield you a really great prototype because you're actually starting to think about the human form prior to going into production. And that's really important and a really good use for 3D printing.
And the studio does have 3D scanning technologies where you can scan your face or arm or something. I scanned my face once and I built a mask off of it that only fit my face, so things like that.
Yeah, things like that. But like, if you're building like glasses or something, you could scan a face, print the face out, and then you can sort of model your glasses on like people's faces and stuff. So it's kind of cool. Yeah. Prototype in a less expensive material. So there are cheap 3D printing materials and there are really expensive 3D printing materials. Like you can print in metal now, but you should always go for the cheap plastics before you jump to 3D printing in metal. I've made that mistake recently, actually. So.
Do we have any other metal 3D printers?
We don't have metal printers here. I know NYU Abu Dhabi has one. And I do know that shapeways.com, they do offer metal printing, but they also they don't print in New York. It's an offsite printer. I do know that Tandon has one, but it is only used for the mechanical engineering department.
Yeah, I was gonna say, I think
It's
they're
pretty
really, they still don't
really
really know how to
exclusive.
use it.
Yeah, metal printing right now is not safe. It uses gases that are highly explosive, so we're not going to be getting one in Manhattan. at least not in an area where there's a lot of people, and definitely not on the NYC campus until metal printing becomes much safer. So we're not at that point yet. But people are printing in metal. You can order a print in metal and have it shipped to you.
How long will it take before it becomes something you can commonly use?
I'm not sure. Not long. I would probably maybe 5 to 10 years. It will be easy to get metal printers.
You can order it and they can make it for us.
You can order it now. You can go to shapeways.com, and there's a couple other vendors. I just only know of Shapeways. And then you can upload a file, order a print, and they'll ship it to you.
Yeah. Does any metal or?
Steel, titanium, aluminum.
Bronze, right?
No, that's cast.
Oh, okay.
But that's it.
Does it do nighttime?
I don't think so. You'll have to check though. There might be someone who's printing that material.
Yeah, and that's the other thing is that just because we don't have a particular resource at NYU, if you're looking for anything in particular, you can ask us and we can put you in the right direction.
Yeah. Nothing is perfect. So all 3D printers have tolerances because it all has to do with how the resolution of whatever is being extruded. So make sure to factor that in your design process. If your material, your walls are going to be a certain thickness, you need to factor that into your design to make sure that everything's going to fit together if you're building parts that need to fit together. So tolerances are very important to factor in. And then printing is not always the end goal. Again, we kind of talked about this. Printing is not necessarily an end. It could just be a means to an end, but it could actually speed up your production time significantly.
Yeah. Could you explain what tolerances are?
Tolerances can mean a couple different things. It can have to do with how thick a feature is, how thick or thin a feature is that you're printing. So if you're printing a box, right, and it needs to be a certain thickness, specific. If your printer cannot produce something to that exact size, usually most manufacturers will tell you what the difference is, what they call it a tolerance. So that means that you may have to add or subtract a certain thickness of your wall to make sure that your production part is producing the right yield. So it's the right thickness.
So that's just all about doing research about the printer that you're using for your product.
Yeah, and if you're not directly using the machine yourself, most people who work with them know those tolerances. So they can say, hey, add 1/4 millimeter to your part to get the right size that you need. So, and that's just something you need to just have a conversation with. Whoever operates the printers might be able to give you a good idea of what those are. And if you're doing it yourself, it's literally just going to be you experimenting. So you're going to want to do a print, compare it to your actual file size, and then make the adjustments from there. So that's what tolerances mean. Yeah. Okay.
Okay.
So should we talk about,
What time is it?
3:47?
All right.
Should we talk about what we offer, what we can do?
Yeah, let's
Cool.
talk about what we can do. Unless you have any more general
Is there any more general
questions.
questions before we get into specifically the technologies that we can offer to you guys right now?
At NYU, yes.
Yeah.
Well, how much is it, like a desktop 3D printer?
They can range.
Like
So I think
1,000.
the Ultimaker is like $3,000, I want to say, maybe. Not including materials, just the printer itself. The Mojos are around $5,000. I would say they can range from anywhere from, I have a $200 printer at home, but then they can go up to maybe $10,000 for a desktop machine, depending on which company.
Yeah.
Yeah, so it's a huge range. I would say on average for a good, reasonable machine, you're gonna pay around $3,000 for a good one.
Ultimaker 3 is going for $3,500.
$3,500, okay, so it's a little more expensive.
Yours is $200.
Mine's $200. It's a micro 3D printer, so it can only print like 3 by 3 by 3. So it's good for like small things like jewelry, which is what I do a lot of the time. And it's a micro printer, so it prints things very fine. But it is a great little machine. But yeah, it was only $200. There is a lot of like troubleshooting involved.
It just depends on
Yeah.
what you're trying to do.
Depends on what you're trying to. It also,
Yeah.
like, if your skill level for handling 3D printers is not great, or you're very new, I would actually recommend spending a little more money to get a machine that's not going to just fall apart on you, that will require a lot of like time with your printer. Like that My Little printer, I remember I was under a deadline for something, I couldn't get a print out of it, so I just printed something at work. And I was sad that I didn't have time to fix the machine, but I just didn't have time. So, that's when not spending the money did not help me out there.
Yeah, and if you come here to the eLab, or if you come
Exactly.
to the co-op or the studio, we have self-service printers that you can be the person running your own prints. And so it's better to experiment probably a little bit at NYU before you start.
Before you spring on a machine.
Like my stepdad did.
And do a lot of research too.
About something like weird off the internet that like was a horrible 3D printer.
Do a lot of research too. Like I know Make Magazine had this huge like end of the year review of like 100 printers that you could buy on the market. And it actually broke them down really well. They tested all of them. So they had some pretty good reviews. So if you're looking into buying one, just make sure you do your research before you spring for one. And then try and see if you can find one locally and then use it and then see if you like it.
Yeah.
If you can. Okay, cool. Any more questions before we continue? No? Okay. So
we're going to talk about materials.
We're going to talk about materials
and prints that have all come off of our NYU printers. So
yes,
you're gonna,
these are all printed at NYU.
Made these.
Yes. So again, LaGuardia Studio is just down the block. You should come visit us if you haven't yet. Same with the co-op. And then you should definitely check the prototyping lab downstairs at the eLab here. Yeah. These were all, okay, let's talk quickly. We'll run through printers a little bit.
Okay.
We'll do a little bit of printers. So LaGuardia Studio has 5 professional 3D printers. And what professional means is that they're not desktop machines, they're like large, giant printers that are used.
The size of like 2 of these tables.
Yeah, they're pretty big. You might see some pictures, I don't know. Yes. Yeah, you're gonna see some pictures of them in the slides. And they're used by several companies all over the world for prototyping. So we offer you guys the professional prototyping experience. That's what we're trying to do anyway. So these came off of the J750 and the Connex 500, which are kind of the same thing. They're a little bit different, but for all intents and purposes, they're the same machine. And they can do actually a lot of samples here. So what Blair's holding.
Yeah, it does rigid and flexible.
It can do rigid and flexible materials.
You hold this same printer, so it does color, and it can also do clear. And so it does clear, color,
flexible
solid, rigid, flexible.
And what printer is this?
This one.
This is the J750. Yep, it's a Stratasys machine.
Yep.
It's pretty new. I think it's about 2 years old now, so it's a brand new printer. And it can do embedded colors in clear plastic, which is a huge seller for some people. And it can do full color printing, full color 3D printing. I'm sorry?
How much?
How much to buy the machine? That machine was, I want to say, around $450,000. Materials, each cartridge is 2 kilograms of material. It's liquid resin material. And each cartridge of material is probably about $600 to $1,000. So.
And where is that? It's here?
That's at the LaGuardia Studio. And I actually have cards here you can take that has our address on it and a couple of other information about it. But yeah, they can print stuff like this. Now, all of our professional printers, we do charge for using them, but we only charge for material consumption costs. So we don't make you pay for post-processing or consultation charges or any of that stuff. So all you're paying for is the material that you're actually using. So we have the printer, we pay for everything else.
Yeah, if you go anywhere else versus NYU as an NYU student or alumni or faculty, you are going to get cheaper rates here. While 3D printing is still pretty expensive, and something like this could be $100. Somewhere else on like a commercial basis, it's going to be like $300, $400. So try to, if you can, stay in-house, because we are trying to offer you educational experiences with 3D printing.
Yeah, and we're trying to keep it affordable for students, especially who will be using our services. So we're trying to keep it as affordable as possible for the NYU community. And then so this is an example of a molecular structure that was printed, colored, embedded in clear plastic. And then on the right, that's actually our flexible material. It's called Tango. I don't think we have a sample of it here. Actually, this is Tango. No, that's not.
No,
oh no,
the
the
other
other
one,
one you're passing around
it's
is
the
Tango.
little slug.
It's a
that you
little
guys saw.
squishy, the
Yeah.
body, and it's a little clearer. That's the flexible plastic. So that's a sample. That's an example of one of them. These are more samples of, these are actual client work done at the studio. So this is an artist who's actually, he's a game designer. And so he printed out a piece of one of the characters that was going into his video game for his company to see prior to it going in. So this was actually a really great marketing tool for his video game that was coming out, which was actually really cool. And what's nice about 3D printing is you can take assets from video games and print them directly. So there's not a whole lot of work that would need to go into getting this in the game or getting it onto a printer, which is pretty cool. And then over here, this is a Tandon engineering students project. They're working on, I think, flow simulations for fish that are swimming in the water. Mm-hmm. So that's actually printed on the same printer. This was
the tail. It like goes
yeah,
back and
this
forth.
was
It's got a
utilizing
motor.
yeah, exactly.
It's about this big.
It's tiny little fish. And this was actually using our dual material, so it was using Tango and rigid, so flexible and rigid materials in the same print. So this was all printed in the same build. They didn't have to assemble anything. So the actual flexible part and the rigid part prints in the same go. So you don't actually have to print, you don't have to like take a gasket and put it on there. It's like already all together. And then the same goes for on the far right. It's kind of hard to see in the slide, but this is actually,
It has fingers.
it's actually a hand, and it's got the bones printed in rigid along with rigid muscles and veins, but then the whole skin is printed with the flexible material, so the fingers can move and stuff. It's pretty cool. We actually have we may have a sample of there at the studio. You can go see that and feel how it can move in person.
Okay.
All right.
So this is
Do you want to talk about the next printer?
Yeah. So this is our powder printer. This does not shown here, but you saw the donut. It does do color, and the support material that holds up all the layers here is actually just a fine layer of powder. I think we talked about this a little bit. And then when it's kind of like an archaeological dig. You end up with just like a box of powder, and to get it out, you like take a brush and you brush it away and you pull it out, and then we put it into this chamber up here, and we'll blow the air off of it. I mean, we'll blow the powder off of it. And then after that, you have kind of like a brittle powder print that kind of resembles
Sandstone.
Yeah, sandstone. And then we'll dip it in what is it?
Cyanacrylate.
Yeah,
super glue.
cyanacrylate.
It's just super glue. Yeah.
Yeah, and it'll give it like a nice sheen. The color will pop. So that's what we're dealing with there.
Yeah, these are all 3D prints from scans in, I want to say Egypt, but I'm not 100% sure, but this was a conservation project. So these are people trying to conserve sculptures that are getting destroyed. And here's more samples from that printer. So this is an architectural model that we had printed with us. Again, as Blair was saying, great use of 3D printing is for printing architectural models. This is an artist's work from the same printer. The artist's name is
powder.
This also powder. So the artist's name is Josh Klein. You can look up his work. He's a pretty prolific artist in New York, and this is an example of the work that he prints with us.
Yeah.
Okay, resin.
Okay.
All right. So this is the ProJet 7000. It's a 3D systems printer. The 660s are also 3D systems printers. But this is the highest resolution printer that we have here. It can print over, its baseline resolution is I think 1,000 layers per inch. So it's able to produce prototypes that look pretty seamless. It's so high in resolution, in fact, that it can accurately produce bone marrow. And this is actually what the medical school is printing with us. This is I think it's a slice of your tibia. That's from a CT scan, and what they're doing is they're trying to find materials that can accurately simulate bone density. So this is a print from our machine that they published in a paper about simulating bone density in other materials. And these are for like crush tests, so they're trying to stress test like jigs and things for people's knees and stuff. So it's pretty cool. Yeah, you can pass that one around. So yeah, this is if you're looking for like really high resolution print, this is really great for this material.
Just wondering on that one, like how strong is it if I kind of want to?
Well, it's
This
a little
one?
bit flexible.
It has a little bit of flex to it. It is not terribly strong though, so it will break. But yeah, you can flex it a little bit, and don't worry if it breaks because we can reprint it. So it's not a big deal.
Yeah.
Okay, 3D scanning. So those were all of our printers. We also have a new printer that we talked about that's not in here yet. It's the Fortis 450. That is a large-scale FDM printer, and that's the one that can print in the food-safe, biocompatible, and aerospace materials. So we actually offer a wide range of materials for pretty much direct to. It's called a commercial. It's a commercial grade 3D printer, so it's actually can print direct to manufactured parts, which is great. So now you can, instead of prototyping and then getting something made from the prototype, you can actually print things that can be consumer ready, which is great.
Yeah. Ooh, my favorite.
Your favorite.
Okay, 3D scanning. So there's 3 different commonly used 3D scanning technologies. They are called photogrammetry, laser scanning, and structured light scanning. And so photogrammetry is something you can do on your own. You can do it with your iPhone, you can do it with a digital camera. You can take, 100 or so, 360 degrees photos of something like this. If you took a bunch of photos from a bunch of different angles from the top, and you took those photos and you put them into a software, we use PhotoScan at the studio. You put them into PhotoScan, it will generate a file for you. So it will generate a 3D file out of scans. If you are interested in learning how to do that, we will absolutely consult on that. But then in addition to that, so that is something you don't have to pay for. That's something you can do yourself. You can go sit at the studio, plug in some photos, and you can generate a 3D file. But then there are paid services. This is the Faro arm. It is one of the highest resolution scanners out there. What it does is it uses a sensor and 2 lasers. Here there's the red and the blue, and as long as they're intersecting, it will read the geometry, and so it is the best file you will get of really just anything. But it does not pick up color. That's the one thing, is that it picks up geometry but not color. And so that's why we have something called structured light scanning, which is not a slide.
That's okay. That's all right.
Unfortunately, so this is just laser. But they are handheld scanners, and they kind of look like irons for whatever reason, and you rotate around an object. And that's what we typically use for body scanning, and what we also typically use for anything that requires color.
Yes. Yeah, these, this seashell, this starfish and shell, these are from 3D scans that we've done at the studio. So you can actually get a sense of the quality of the scan that you can get with it. Okay.
Okay, so we're on the right side now. I represent the co-op, and Demery represents the studio.
Yes.
So, so there's a few differences between our services. They are technically a shop over at the studio, a 3D print shop. So you'll get the professional grade. All of these prints came off of the beds from the 3D print shop. They will do project consultations. So if you are really interested in making something for your business, your startup, you can make a reservation by emailing them. What else do you guys do? File review.
Yeah, so if you're working on a project and you need some direction, you can email us and we can offer consultation, like they're free consultations. It's an hour long. You can get as many as you need for your project. And basically we'll sit down and help guide you on what you need to do. We also, and so those are free services. We also offer a project consultation, which is a rarely used service, but we do have it, and that's a paid for service where if you really want help with your project, you can actually sit down and we will help build your project with you in conjunction, which is, it's an hourly rate. So we can actually sit down and help you make your object and make your project.
Instead of just referring you to softwares and referring you to
Yeah,
services.
we can like for free, we'll help guide you to what you should be looking at, and we can help you with simple file issues or software issues you may be running into, and we can give you some simple design guidance, but we can't actually sit down and work with you just because we're a very small team of people, and we
specifically can't make your file for you.
Exactly.
So if you come in with an idea,
Yeah.
you say, I have an idea, I would like to make a gumball dispenser, whatever. But you don't necessarily have the tools yet to do so. We can point you to the right softwares. We can talk to you about how it would be printed, whatever, etc. But we will not make it for you. So unlike over at Tandon, you can go in with like a map of what you're trying to make, and they will make it for you. We will not do that.
Yes.
But go ahead.
But what's great is that we are open to the entire NYU community, so it's not limited to students. We are open to staff, faculty, admins, alumni as well. So as soon as you graduate from NYU, you can still use our service. So we still let you guys come in as long as you were formerly a student or faculty or admin.
At the same low prices.
Yeah,
which is a
we
huge
don't
deal.
have tiered pricing, so you're still paying the student rate.
So that's a big advantage. Okay, so we are different in that we are only open to NYU students and faculties hosting student events. So we are a student facility. We do have 3D services, but we also have, VR, and we have the Oculus and the Vive headsets, and we have teleconferencing centers and a Mac lab, and we do have two self-service 3D printers. We have the Mojos, and we have 3D printing workshops. So if you're trying to learn how to 3D model, we will teach you. Just come to one of our workshops. But we have a lot of other things: group meeting rooms, flexible collaboration space, tons of projectors, that kind of stuff. We're essentially a co-working space.
And
And
workshops are only open to NYU student faculty.
only open to NYU students technically, but we do make exceptions for faculty.
We do.
Just email
And
me.
staff. Yeah.
And staff, just email me. But we do, we are essentially NYU's souped up computer lab. And so because of that, we are technically for students. Okay, that's it.
This is again kind of reiterating what you can do at the LaGuardia studio. So you can print objects in plastic and sandstone, you can 3D scan. We also offer wide format archival printing services. So if you're an artist and you're printing a giant photograph for a gallery, we can do it for you. If you're printing a poster for an event, you guys will be getting the poster printer, so you can print
Come to me if
posters.
you're trying to do a poster.
But unfortunately, the papers we use are too expensive, unfortunately, for most people's needs for posters.
All the Tisch photo students go to the studio.
Yeah. So, but if you're printing photographic prints, you should definitely come and use our services. And again, we do free consultations, so you guys can come by and ask us any questions about anything, and we can help you out. We may not know a lot about other manufacturing processes, but some of us do. So if you're kind of looking, you're going down the hairy road of like some process and you're not sure about it, we might actually have some knowledge on that. So you can still ask us questions that are unrelated to 3D printing, and we can talk to you about that. Cool. Yeah, so this is, you can actually see this is our storefront. We have a little flag so you guys know where we are. This is the self-service area, so you can reserve computers and sit down and work on your files. We have a ton of 3D software that you guys can use, as well as 2D software. This is kind of what we have here. This is our business counter. This is where everyone can come in and talk to us.
This is just the photo section.
These are just photos, yeah.
They're essentially like things we've already talked about, but
This is just like stuff that we have. That's me.
different hair color.
Exactly. This is a while ago. This is an old picture. And then these are some of our printers that you can actually see. So the SLA, which is the high resolution printer, is that kind of refrigerator looking one in the back. It's about the size of a refrigerator. And then the J750 is this guy that's kind of, longer and shorter.
Not the best photos.
Not the best photos. These are old photos too, because we no longer have the Connex that's down here. Instead, we have the Fortis, which is that giant, beautiful FDM printer. But this is what our basement looks like. If you come over to our studio, we can schedule you a tour if you really want to see the machines and talk about them, because they're fun to watch when they're printing. And you can see what we do. And then this is our little scanning area.
Oh, these are the little irons, little handheld scanners. They're very unassuming, but they are very powerful.
Yep.
Okay, so
yes.
this is over at the co-op. We do our tech talks and our workshops. There's a 3D modeling software called Medium, which you can actually do in VR with the VR headset.
It's really cool. I've done it. It's
awesome.
Great.
So we did a workshop on that recently. Also, if you want to just come try it out, all you have to do is give the front desk your ID, tell them what you want to do, and they'll set it up for you. If you're ever trying to try any sort of VR game. We've also done ZBrush, Blender. These are 3D printing softwares. And just this one was just a lecture, another lecture, and SolidWorks is an engineering 3D modeling software. I'm sure some of you have heard of this. MeshMixer is free. MeshMixer is a free 3D modeling software, few and far between, that are actually awesome. If you want this on your laptop, you can have it. It's great. But if you want to be using these more expensive ones, SolidWorks and ZBrush, Blender is also free, then you can use them at both of our labs. We have them, which is awesome and rare to have access to those 3D modeling softwares. Cannot sell it more. So we do tons of things like this. If you are ever interested, please let us know. We will put you on our mailing list.
Awesome.
Oh yeah, this is the self-service printer that we both have. It's actually this is accurate to size, I would say.
Yeah, it really is about that size.
It's about this size. It looks like a easy bake oven. It is. Yeah, on these self-service ones, you can print 5 by 5 by 5 inches. Which is, you get about this big. So it's not a professional service, but it is a great printer, and you don't have to chip off the support material. It dissolves in a bath of lye, which is amazing.
Not as much post-processing, which is great.
Not as much post-processing. Yeah. Okay. And then these are the softwares, which you may or may not have heard of them, but they are softwares that we actually allow you guys to use on our computers. Anyone can use these. Please consult with us. All these different 3D modeling softwares do different things. And I know it can seem a little bit intimidating, but all you have to do is ask us. I am an artist and I use ZBrush, but I also use MeshMixer. And when I'm trying to make something that's a little bit more like this, like engineering-like, I use SolidWorks. So depending on what you're trying to make, we will send you to different softwares. So you just have to ask.
Yeah.
Oh yeah, and this is our contact information.
Yeah. If you guys are also looking for modelers, like for hire to do your project or help you build things for your project, you can email us at the studio because we have some contacts that we can actually direct you to. Some of them are students, which is great. You're actually helping the student community make some money on the side. So we love to push freelance work towards our student staff because that's really good for them.
If you don't want to make it yourself, we will know someone who will make it for you for money.
Exactly. Exactly. Which I know a lot of people are interested in, is like finding people who can help them do the work, especially if you're under a timeline and you don't have time to actually learn all the software, even though we really would like to encourage you to learn 3D software, because you'll actually make better prototyping and design decisions if you understand the technology you're working with. And that's what is good about 3D modeling.
Yes.
So.
Cool. Please raise your hand if this was overwhelming.
Too much information.
Too much information.
That's good. That's okay. I think are you guys gonna send them the materials?
Yes, so I will follow up with everyone who attended today immediately after this with this deck, as well as a few additional events that may be of interest to you. As far as upcoming startup school sessions that we have, tomorrow, Thursday, we have Julio Terra, who's an early employee from Kickstarter, coming to lead a session on how to crowdfund for your business. It's been great. Next week, we have on Tuesday a session on pitching for investors. And then on Wednesday, a session on design thinking. So that's all under the Startup School umbrella, which is this event series where you came today. One other thing that I think may be of extreme interest to many of you is one of the funds that we co-own with the Tandon Makerspace Greenhouse is the prototyping fund. And that is something that we offer every semester where we select teams and we give them up to $500 for phase 1 and up to $2,000 for phase 2 to just build prototypes. So this is a fund that we've created just to kind of support prototyping. We've found that sometimes the cost, $200, $300, can be a barrier towards someone actually building something. So we help you by providing funding to build those things. And on next Tuesday, so that should be the 25th, is actually our showcase. So if you join us from 12:30 to 2:30 next Tuesday at the Tandon Makerspace, you can see all of the prototypes that have been built over the last year, so the fall semester and spring semester. And many of these prototypes were made with 3D printing, so this will be another
So exciting.
awesome next step.
That's awesome.
So those are
Cool.
my updates.
That's very cool, actually.
Okay. Any questions at all? Yes.
Yeah.
Where should I start if I wanted this prototype to be?
Yeah.
I mean, I think the first question is, do you want to learn how to make it yourself?
I do, but I'm on a timeline. I have a
Okay.
full-time job and
Yeah.
I do school part-time, so it's coming up, and the second week of May that I need to.
If you're looking, if you're looking for a 3D modeler, email these guys.
Yeah, email us. Give us a little blurb about your project. Do you have any 3D files for it yet? Okay. Do you have?
I'm willing to learn, but I
Okay.
don't know if I have time at all.
Yeah, that's okay. I mean, do you have drawings or do you have
I have
any?
sketches.
You have sketches. That's good. That's a good place to start. Okay.
I've done Photoshop like way,
Okay. Good. No, that's perfect.
15 years ago.
Yeah, no, that's perfect. So basically, yeah, what's going to happen is you can send us materials you want to send us, just enough that we can find someone who might be interested in working with you, or we'll direct you to. There's a couple other companies that offer design services, and we're actually in contact with them, so we can actually direct you to a host of different people who can help you build your file.
So just send a comprehensive email,
Yes.
essentially.
Yeah.
Yeah.
And that's perfect. And then we'll set you up with a modeler, and then you guys will just start building a file. And then once you're at the point where you can print it, you can contact us, and then we can, or actually any of your contacts really. And there's a couple places at NYU that you can print with. But you can contact us if you wish, and then we'll set up an appointment with you and your modeler. Hopefully, if your modeler's in New York. If not, we can speak to you about it. And then we'll start printing. But yeah, since you are under a tight deadline, I'd email us as soon as possible so we can get you in contact with someone who can help. Cool. But we'll want you to get you set up with someone who knows SolidWorks, which is a CAD program, since you're building a very much an engineered machine. So, cool.
I do know someone who might be able to model.
Okay, good. Well, that's even better. Yeah. The Tandon is full of engineers, so there are people there too that may help you as well.
Okay.
So, yeah.
So I've got some questions, but they're very specific. I'm not sure if I will answer here.
You can, yeah. I mean, shoot.
So I'm working on a project to, I don't know if you know about pallets. There's kids.
Mhm.
So to move the pallets, to expand them, level them, and bring one of them forward. So it's three-dimensional movement of the pallets. And what I'm trying to do right now is use metals to do that. But I was wondering if I could use plastics with shape memory instead. Because I saw something online, like glasses that are made with shape memory polymers.
Yes.
And I was wondering if you could use the same with 3D printing.
I vaguely remember reading an article about 3D printed memory plastic. So I think people are doing it.
It's just not at NYU.
I mean, we don't have those materials,
Yeah.
but I think there are people doing it. I would Google that, because if you can get in contact with the people who are working with the memory material, that would be a great project for them. And
But it's not at NYU.
not at NYU. Yeah, no, unfortunately
Do you know
not.
if it's a strong material? I need a lot of
Yeah, I don't think it's going to be a very strong plastic.
Yeah,
Most,
have a good one.
with the exception of some of the like the Ultem, the high heat, high impact materials we have at NYU, most 3D printed materials are pretty brittle and will not be able to withstand a lot of stress. But so that's something you're going to want to look at. I imagine a memory material is probably not going to be very strong. But yeah.
And in the future, when
Mhm.
metal, commonly used metal
Mm-hmm.
printers, then you can use that, right? So
Yeah.
you can feed any metal to it, or
It's going to be specific metals. Each metal compound that they 3D print with requires different, temperatures for heating the material, requires different gases to assist in the. It's basically it's always going to be an alloy, because that's how they get the. Basically, what they'll do is they'll either sinter or use glue to glue the powdered metal material together, and then what they do is they burn out the whatever third-party thing is holding them together. Sometimes it's bronze. So it's going to always be an alloy. It's never going to be a straight up material.
Stainless steel.
Stainless steel. Yeah, it's stainless steel, titanium, and aluminum. I think that's all I know about right now that they're 3D printing with. A lot of people will do casts. So they'll 3D print in wax and then they cast into whatever material they need, like surgical steel or other processes.
So do we have the material to make the cast for those things?
It's coming. We have a bid to get a wax printer in 2018. So next year we will have a wax printer at the studio that you guys can use. But we just don't have it yet. But it's coming. It's like our next thing on our wish. We have like a wish list that's like 10 years long. So that's like the next one on our wish list is the wax printer. So yeah, that is coming.
That's true.
But yeah, you could take that wax and then cast it in any material that can cast out of wax. So cool.